Imaging, sampling, and quantization. To create a digital image, we have to convert continuous sense data to digital form. It involves two processes. These are sampling, quantization. To convert to digital form, we have to sample the function in both coordinates and its amplitude. Sampling. Digitizing coordinate values are called as sampling. Quantization. Digitizing the amplitude values are called quantization. Number of intensity levels typically is an integer power of 2. Often 256 is to 1 byte equals 8 bits per pixel. The discrete levels are equally spaced. Sampling. Effects of reducing spatial resolution. Sampling of function f of x, y, fe of x, y equals f of x, y into sigma I, sigma j, del of x minus I, delta x, y minus j delta y, delta x. Sampling distance in direction of x delta y, sampling distance in direction of y. The value of function x, y at x equals I delta x and y equals j delta y. The mean value of function x of y around I delta x, j delta y. If function x, y is weighted by h and integrated over r, f bar of I delta x, I delta y equals integrated over f of x, y into h of I delta x minus x, j delta y minus y into dx dy. Sampling distance limits lead to a reduction in resolution. Structures of about the scale of the sampling distance and finer will be lost. Sampling theorem. We will obtain a periodic structure correctly only if we take at least 2 samples per wavelength. Else, Moore effect. Sampling theorem is a fundamental bridge between continuous time signals, often called analog images, and discrete time signals, often called digital images. Representation of images. A rectangular grid is only the simplest geometry for a digital image. Delta x equals delta y. Other geometrical arrangements of pixels and geometric forms or elementary cells are possible. Digitization process requires decision about values for m, n and for L, discrete gray levels allowed for pixels. Number of gray levels typically is an integer power of 2. L equals 2 raised to the power of k. Discrete levels are equally spaced and that they are integers in interval 0 to L minus 1. This is known as dynamic range of image. Number of digitized bits b required to be stored in an image. B equals m star n star k. If m equals n, equation becomes b equals n squared k. Spatial and intensity resolution. Spatial resolution. Sampling is the principal factor of determining the spatial resolution of an image. It measures the smallest discernible detail in an image. Spatial resolution can be star in number of ways, such as line pairs with unit distance and dots per unit distance. Intensity resolution. It is referred as the smallest discernible change in intensity level. Intensity levels usually is an integer power of 2. Number of bits used to quantize intensity is called as intensity resolution. Image interpolation. It is a basic tool used extensively in tasks such as zooming, shrinking, rotating, and geometric corrections. Interpolation is a process of using known data to estimate the values at unknown locations. Nearest neighbor interpolation. It assigns each new location the intensity of its nearest neighbor in the original image. Bilinear interpolation. Using 4 nearest neighbors to estimate intensity values at given location. Let x, y be the coordinates location to which we assign intensity value, and v of x, y is intensity value. Thus, equation of bilinear interpolation, the assigned value using following equations. V of x, y equals ax plus by plus cxy plus d. Bicubic interpolation, which involves 16 nearest neighbors of the point. Intensity value assigned to point x, y is obtained using equation v of x, y equals summation of I equals 0 to 3, summation of j equals 0 to 3. Aij, x raised to the power I, y raised to the power of j.